All right, so in this section, we're going to talk about the state node. It's going to be more an introduction to the state node in hopes of piquing your interest to look into it further. So the state node is pretty awesome actually because it gives us access to the information about the rays that are being cast by redshift. And we can do some pretty powerful things if we combine the knowledge of what the rays are doing with just a little bit of math. And I'm going to give you two quick examples of some things we can do. But firstly, let's talk about some of the things that we can get by using the state node. So to get most of the data out of the state node, we need to click on the red box on the right-hand side. And you'll see we get a number of these weird names. You'll see we get things like ray length, ray origin, ray position. And in this chapter, we're going to go over ray position and ray length. So let's start with ray position. It's going to look kind of weird. Essentially, what this is giving us per pixel on our shaded surface is the ray intersect position, or the first ray, the primary ray that's cast by the camera, or cast from the camera rather, to its first intersection with the surface. Each pixel value here, even though it just looks like blue, green, yellow, and white, has a slight variance to it, and that variance is describing where in world space the ray struck the surface of this shader. So if you can imagine that we put a dot on the dragon here, object, for each pixel that hits the surface, we'd have a bunch of dots scattered all over the surface of our dragon geometry. And with just a little bit of math, we're actually going to be able to make what I would consider to be a volume selection with fall off. So the idea here is we're going to have our little selector point here. So essentially, what we can do is we can actually take the selector and just drag it straight into our shader graph, and we're going to be able to get its global position. So let's snag that. Now, if we have the position on the surface in world space of our currently shaded object, and we also have a second position, what we can do is say, okay, my primary ray went into the scene and struck the dragon at this point. Now, what I want to do is take another point. Let's just pick this one over here. And we're going to say, let's see how far away that point is. And the way we do that is by subtracting the positions from each other. So if I take position 1 and position 2 and subtract 2 from 1, it's going to give me this vector. Then what I can do is I can measure the length of this vector. And essentially, by doing that over all of the points on the surface, we'll get a fall off. So for example, let's say I take another point on our surface over here. Let's color this guy, I don't know, let's color it orange. So now we're also going to say, let's subtract this point from point 1. We're going to get this vector, and let's get the length of that guy also. And then we'll do it for other points. Let's pick a pink. So then we've got this point way over here. And we're going to say, okay, let's get that vector and measure the length of that. So you can see we're going to get a bunch of varied lengths as the result. For each point that we measure this from, we're going to have a varied distance based off of this one original point. And that's all we're doing over every pixel on the surface of this dragon. So let's go ahead and put that into practice. I'll move our point over here since that's where I was drawing all this crap. Just put it, I think we're pretty close. Let's double check. Yeah, it's pretty close to the surface. Okay, so we're going to take our ray position, or ray intersect, and we're going to subtract. So we'll grab our vector sub. We're going to put our selector position into input 1, and we're going to subtract every pixel on the surface of the dragon, subtract those two positions. You can think of this state node as returning a value for each pixel on the surface. So this guy actually represents all the pixels on the surface of this geometry, and whatever we set up here is going to run for each pixel on the surface. Just to go over again what exactly we're doing. For every pixel on the surface, subtract its position by the position that we select. So that's what we're doing here. Now what we want to do is say, cool, we have a bunch of vectors between this point and every pixel on the surface of the dragon. Now let's measure the length of those. So we can drop down our vector length node, pipe that in, and we can look at the result, but we're not going to like it. So right now it returns all black. I'm not actually sure why Redshift does this. It should be outputting a float value, which is the length of all of our vectors that we just created. So in order to actually get this to work, we need to drop down a change range, which is going to allow us to change these values into something that we can use. Now we've got our change range. I'm going to go ahead and unclamp it. So right now, everything's white because the scene is based in centimeters. That is our unit size. So right now, all our values are over 1 because all these pixels are beyond 1 centimeter from our point here. So if we just take a handy dandy cube, drop that in the middle here. I just scaled it down. Let's say that's roughly the size of our thing here. So let's see, that's 43.92 centimeters. Let's just say 50 centimeters. So if I scale our input to show me up to 50 units away, we should get a nice little fall off, which we do. So we're just going to go ahead and flip the new range min and new range max from 0 to 1 to 1 to 0, and that's going to give me my nice little volume fall off. So now I can go around here and select any part of the object that I'd like. Further, I can go toss a ramp in, flip it to alt mode, and pipe that out to our surface. And now we can somewhat easily remap our values. And of course we can actually expand, the reach as well. And just to make it super interesting, let's go ahead and pipe this into the material blender example. We're going to pipe the data into the blend color 1. Now you can see, move this guy back, that wherever I select with my little selector dude, we're changing the material. This is all being done at render time, which is super cool. Okay, let's look at a second example. Just going to take all this stuff. I'll move that out of the way. And let's drop down another state node. And we'll keep our transform space in world space. This time we're going to get our ray length. And all this is going to do is say, all right, rays, I see you've casted into the scene and intersected the dragon at this point. Give me the length of that ray. That's all we're doing. So initially, if I throw ray length into the surface, you're going to see it's all white because in order for it to be black at all, it would have to be under 1 centimeter in distance from the camera. So again, we're going to drop down a change range. In this case, it is a float value, so we don't need vector change range. We're going to pipe it into input, and we'll take a look at the out. Now, we want to display from 0 to 1, so we'll leave our output as 0 and 1. But our input, we're going to say, all right, show me from 300 centimeters in to 350 centimeters in. Let's see what that gives us. So our minimum range is going to be 300, which we want to represent as black. So 300 centimeters into the scene should be black. And 350 centimeters, whoa, that's 3,000. 350 centimeters into the scene should be white. Okay, we're kind of clamping off our values here, so maybe I'll lower those numbers a bit. Let's try 250 will be our minimum. Maybe 225 will be our minimum. There we go. So now you can see this is looking a lot like a z-depth pass. That's because a z-depth pass is precisely this. It is the length of the ray from the camera to the object in the scene. So now that we've got, maybe we should increase this to like a 400 so we get more of a gradient across the object. If I throw a ramp in here, set the ramp to alt mode and pipe that out, we can now go and change this guy and select. Could even add another black node on the end there if I wanted to just select a certain portion from the camera. This could also be kind of fun to plug into our blend color for the material blender example. Let's see what that looks like. Whoa, it's not happy with that one. What happens if we just look straight at... Actually, we probably want to invert that, don't we? So now, based on the distance from camera, we are blending our materials together. That's pretty cool. And this is just honestly the very beginning of what you can do with the state node. And if this inspired you at all, I would Highly recommend looking just a little bit further into how ray tracing works and what exactly you can get out of the different options available in the state node. All right, well, thanks for checking out the state node section, and we'll catch you in the next one.